All right, so we are continuing with related rates. I asked you to write down on here what you needed to know, what you know, the same little process we started with yesterday, right? Okay, so as we read this, it says the radius of a cylinder, so the radius is decreasing at a constant rate of 5 feet per second. Volume remains constant at 36 pi cubic feet. At the instant when the height is 25 feet, what is the rate of change of the height? Okay, and there gave you the volume of a cylinder. Right, so what is it that we are looking for? Awesome. How do I write that down? dH over dt. Can't read your handwriting, that's the problem. dH dt. Okay. So this is what we are looking for. What would the units on dH dt be? What are the units for height? Feet, okay, and then per second, okay. So feet for height, seconds for time, yes? Okay. Do we know the height in here? Yes. What is it? 25 feet. So at the instance when the height is 25 feet. Okay. Got that. All right. So let's see what else we got. Start back over reading it again. Starts by talking the radius of the cylinder is decreasing. So that gives me what information about the radius? Yes, that it's decreasing, but okay. It's what is it? There you go. The rate is negative. So I write that as d what? dr dt. And since it's decreasing, it is negative 5 feet per second. Disturbing. All right, do we know the radius at this point? No. No, we don't, right? But what would the units be on the radius? Feet. Okay. All right. So then, what else? So we have R, and we have H, and it says, so we talk about the radius. Then it says the volume. Okay. The volume remains constant at 36 pi cubic feet. So the volume, I know that part. This is 36 pi cubic feet. You agree with that? So then what is dV dt? Is it 0? Does it make sense? It's a question mark? It's 0 because it's constant, because it's not changing. Right. This is the rate at which it changes, yes? If it's constant, so this, we have a number here, but it's not constant at 25. That's just at our instant that we're using, right? But it says constant. That's important. That means it's not changing. So that's 0 feet per second. Okay. We good with that? Okay. So we have our function. Let's rewrite that. The volume is pi r squared h. What do we need to do with that? Plug it in. Plug what in? Okay, so I can plug height and volume in here. Go ahead. To find R, because that's one of the things that we don't know. Are we sure that we need R? We might. But I want you to think about this. There were some other things that when we wrote down all of this, that, let's see if I can find one of them. And maybe we didn't come across that yet. Oh, maybe we haven't come across one yet. But it is possible that maybe even though we put a question mark, maybe in the end we don't need it. But we find it, so let's find it. Maybe we'll need it. So we plug in what we know, or substitute in what we know. We know the volume. What's that? 36 pi. Okay. That's equal to pi times r squared times 25. Divide by 25 pi. So when I divide both sides by 25 pi, those all cancel out, right? These pi's will cancel out, so I get 36 over 25. equals r squared. Take the square root, r equals 6 over 5. So 6 over 5 feet. Okay, we good? Are we done? No. And now I need the derivative. Okay. Could I have found the derivative first? Yes. Okay, so let's see what happens when we find this derivative. So we have the volume, it's pi r squared h. Right, we're going to take the derivative. It's the derivative with respect to what? What's d over dt? Good. Okay. So the derivative of v is 1, and then dv dt, right? So I got dv dt equals, now I know I'm doing implicit differentiation. What rule do I have to use here? Product rule, good. So that pi I can leave out front, or I can attach it to r and let it be part of the pi r squared. What would you rather do? Leave it attached, is that what you mean? Okay. So we'll leave it attached. So that means I'm going to multiply, so I take the derivative of the first, 2 pi r, don't forget dr dt, times, so that's the derivative of the first, times the second, plus the first, which is pi r squared, running out of room, times the derivative of h, which is just going to be what? dh dt. Okay. Everybody with me so far? Okay, so what do I do next?
Plug everything in.
Plug everything in. You're right. So do we know dv dt?
Yes. It's 0.
It is 0. That is equal to 2 times pi. Do I know r?
Yes.
Yes, it is 6/5. Do I know dr dt?
Yes.
Yes.
Negative 5.
-5. Do I know h?
Yes.
Yes. 25. Okay. Plus, then I have pi. What was r?
6/5
6/5
squared.
squared.
No, we don't know.
Then we don't know that one. That's what we're looking for, right? Everybody with me so far? So had you just done what we did, so let's say we didn't do what we did in purple. We said, oh, you know what? I know I'm going to have to take the derivative. You take the derivative, you get here, and you go, okay, I'm going to substitute everything in. When you substitute everything in, and if we hadn't found r, we would have r here and r squared here with this, and then that would have told us, wait, we can't have two unknowns, we got to go find it. That makes sense? And that's one reason why writing it all out, and then you think, how am I going to go find it? Well, we use everything that we already know, okay? Because that may happen that you may not think to do that first, and that's okay. All right, so let's clean this up a little bit. Let's see. I can cancel this 5 with this 5, right? Negative 12 times 25 times pi, yes? Well, I just multiplied the 2 times the 6, and I just left the 25 because I don't want to do 12 times 25. We okay with that? Okay, plus. Oh, it's fine, yeah. I'm just conditioned, I think, not to, but it's not wrong. What did I do? No, well, hang on. dr dt, this is r, this is dr dt, which is negative 5. And I just canceled it with that 5 just because that was an easy thing to do. Okay. You don't have to, but I just did because if I can get rid of my fractions, I'm going to get rid of my fractions. And then this is 36, oh, that is a pi. 36 over what? 25 times pi dh dt, right? What are we solving for? The only thing I can solve for, right? So I'm going to move this over. Do I have to actually multiply it right now? I don't have to. Negative 12 times 25 times pi equals 36. Oh, yes. Thank you. Okay, I should say legally move it over. You can't just literally move it over. Over 25 times pi dh dt. And then divide. Can I just go ahead and divide both sides by pi? And just say that that's gone, right? And then when I divide by a fraction, I'm actually going to do what? Multiply by the reciprocal. So I'll have 12 times 25 times 25 over 36. Would that be a safe stop as far as the multiplication and whatnot. Okay, so this is going to so I can say dH dt equals this, but what am I missing? Units. What are my units? Feet per second. Do I have to actually think about what it is? No, because we wrote it down when we started. So if your brain's mush at the end, you already have it there. Okay. We good? And notice what happens since I didn't multiply it all together. Let's say that it was, hey, I am still talking. Let's say that it was a multiple choice and I needed an actual number, right? The fact that I didn't multiply everything out, can I reduce the 25 and the 36 at all? No. But I can do the 12. We should know what 25 times 25 is. I'm going to disown all of you. You weren't here.
I said 625.
Oh, 625. I'm sorry. I thought you said I wasn't here, like you were absent the day we learned that or something. 625 over 3 feet per second. I'm going to tell you again, you should know your perfect squares to 25 to simplify things like that. Okay? What questions we got? All right. And by the way, I'm just looking at what I wrote down. What I wrote down, because I was thinking I had a lot of other stuff written. I actually did multiply it out, and then my reducing was a whole lot more of a mess. What questions do we have? We good? All right. So those of you that actually did what I asked you to do in pink, did you do it right? You feel good about it? One time? Okay. So I want you to look at this one. Let's talk about units, and then I'm going to have you write this down. So we're talking about the volume of a cube decreasing at a constant rate. At the instant when the side length of the cube is 5 feet, what's the rate of change of the surface area? So I would say for the side length of a cube, we can use S. For surface area, just use A for area. Okay? And then write down what you can get out of this. You should have 3 DVD somethings along with that information. That's volume, but it's a cube. We'll talk about the formulas in a minute. Get that written down and we'll talk about the formulas. Well, I'm going to show you what you can do when you don't know them to dig them out of the back of your brain. So you used an L where I'm going to use an S, and that's fine. You can leave it like that. I don't care. That's okay. Well, that's why I would use just A here instead of SA. But again, you can use your variables, and it's okay. You're fine. I just don't want it to get confused when I'm writing stuff. You know what I mean? Okay. Even though it's surface area, I would just use A. What's,
So it'd be D.
don't worry about it yet. Just get this part. You don't need to know the formulas to get written down what you need to write down, and then we'll talk formulas. I knew I should have talked about the formulas first because that's all you're obsessing over. We good? Area, any kind of area is always squared. So on formula charts, you will see that surface area can be written as SA or even a capital S. But the capital S or the lowercase s can get confusing, and that's what Marco was saying. So he was using L, which is fine. It's like he was reading my mind. That's actually what I've written down over here. But I think area. Miss Bruce convinced me area makes the most sense. Okay, let's talk through this. So volume of a cube is decreasing at a constant rate of 475 cubic feet per minute. At the instance when the side length of the cube is 5 feet, what is the rate of change of the surface area of the cube? So we are looking for the rate of change of the surface area of the cube. So I write that as d what? dA dt. It's okay if it's not the first thing you wrote, but it needs to be on here. So that is equal to a question mark, but we want units, okay? If we're talking straight up actual area stuff, I'm not going to say when you always find the area, your units are always cubed, because we'll find that that is not true. But when we're talking about, you know, it does say volume is cubic feet. That's how we know area is going to be units squared. So area, let's see, those are feet. So it'll be feet squared. And what's our time unit here? Minutes, okay? So that means since I looked for dA dt, I need to know, do I know A at this point? No, doesn't mean we can't find it. We'll get there. It's feet, okay? All right, so then it's also talking about volume. So dV dt. What is dV dt? Negative 475 cubic feet per minute. Yes? Okay. Did they give us the volume at this instant? No. Oh, look what I did. Y'all didn't fix me. What did I do wrong on my area? Where's my squared? Why didn't you call me out? So what's volume? Feet what? Cube. At least I caught myself, right? So side length, at an instant when the side length is 5 feet, which means it's changing, right? So I also need ds, meaning side length, dt. Did they give me that? No. Okay, what are my units here? Feet per minute. Do I have a side length that I'm actually using? Yes, and it is 5 feet. Do you see how we got all of that out of there? Okay, those are all pieces that we need. Now, we can, because we have this, we can actually find these things, but we have to know our formulas. And this is not a formula that you will be given. Am I correct about that? Okay. So you have to know some things about a cube, right? So let's draw a cube real quick. You can draw a square, and then you can draw another square like overlaps it, and then you can connect them, and it's not perfect, but it gives us something to talk about, okay? It's really, hey, if I can draw it, you can draw it. You draw a square, and you draw a little square overlapping it, and then you connect the corners. Trust me. I know. Look at my beautiful cube. Tell me things you know about a cube. It's 3D. Perfect. The faces of a cube are what? There's 6 of them.
They're even. They're the same.
They're squares. And what's the fancy geometry word for the same?
Equivalent.
Equivalent. Not just similar, but better than similar. Starts with a C. Anybody?
Congruent.
Yes. Okay. So I have 6 squares, and they're all congruent. Yes? Tell me what you know about the sides of a square.
They're all the same.
They're all the same. So so where the squares come together, since we had COVID geometry, these are called edges, right? See these edges? Those are like the sides of the square. Okay? So since all the sides of the square are the same and all the squares are congruent, every single edge is just S for side length. Right? So I need 2 formulas. I need the surface area and I need the volume. So let's talk surface area first. Oh, here, look at me writing the essay. It's back to my geometry days. It is the surface. It is essay, but okay. So I want that looks like a 5. It's an S. Make sure you can read your handwriting and mine. If I find how do I find the area of 1 square? Length times width. What is S times S? S squared, right? That's the area of one of the squares. Okay, so this is S squared. Well, that's S and that's S. So this area right here, that is S squared. How many of them do I have? 6. So my area is 6S squared. Sorry that they look like 5s and sometimes my board doesn't. Does that make sense to you? Surface area is literally the area of all the surfaces. You have to at least get that out of geometry. Okay, even if you don't memorize the formulas. At least you remember triangles. All right, then we have volume. What did you tell me about? You were talking about volume earlier. What is the volume of a prism or of a box? Length times width times height. Does that make sense? It's also big B times H. Okay, so length, what is this length right here? S. This is S. Length times width times height. This is just S cubed.
It's because we learned it like right when we went on that one app,
Yeah.
and so the
Oh,
person
yeah.
who was teaching me, I didn't, they were doing it weird. It's not as simple.
Okay. But does that make sense? Do you see how if you don't just straight up know them, you have to think about what you do know about the figures so you can get the formulas because you actually need them. Okay, we good with that? What questions you got? Okay. So let's think about what we're looking for and what we can find. The rate of change of the surface area. So I want the rate of change of the surface area. So that means that I need to actually take the derivative, right? So let's take the derivative with respect to time.
Why are we taking?
Because that's what I'm looking for, okay? So this gives me dA dt equals what? 12s 12s ds dt. Okay, we good? Do we know ds dt? No, we don't. Do we know, let's see, what could we figure out here? We can figure out A.
We could figure out B.
We can figure out V. All right. Okay, let's do this.
If you take the derivative of S, then it's 0, so is ds dt 0?
If I take the derivative of S, no, doesn't work that way. But it's not constant. Yeah, that's why. It's not constant. That's why you can't. Because yes, we have it. That's a very good point. That we have it, but that's at an instant.
It says at the end.
Yeah, at the instant. But it's not. If it was a constant, if side length was always 5, then we could. It's not a constant. It's at that instant. Okay, but look, they talked about, we want area stuff. They told us a whole bunch of stuff about volume, right? So we could find the volume, you said, right? But we probably don't need to, all right? But what else could I do with volume? dV dt, because I know what dV dt is, right? Look at what you have. And so if they've given me this, maybe I need to use it. Maybe not, but we'll see. So we get d dt of this. So we get dV dt equals what? 3s squared ds dt. Okay, so if you look back over here, we were looking for this. We did know s, but we don't know this, right? Oh my God, we can solve for ds dt. Yes? All right. What is dV dt?
-475.
Woo! In stereo. That is equal to 3 times 5 squared ds dt. This table over here is kind of quiet, though.
They don't ever see. Look at
So what do I do with this?
You can square the 5 and then multiply and then divide that by.
Okay. So let me show you something else. This, well, 5 squared is 25 times 3 is 75, right?
Yeah.
Okay, I'm going to leave it as 3 times 25. I can just square the. I'm going to show you why. You just hold your horses there, mister. There's nothing wrong with doing what you were saying. That's right. Sometimes, oh, what am I doing? See, maybe you should doubt me. I'm just making stuff up now. All right, so those are going to cancel out. If I want to reduce this, which I'm thinking I probably do because I have to go substitute it in somewhere else, right? Like, could I leave it? Yeah, but yuck. If you got 25s, you can think in terms of money. You have $4.75. How many quarters do you have? Is it?
It's 1, 2.
Oh no, I was doing the
They're doing the 4. Okay.
the 4.
You have 19 quarters, yes? Yes. Okay. So 475 divided by 25 is 19. Negative 19 over 3 equals ds dt. So although you get in a hurry to always like multiply everything together,
You said 400 and I said 60.
it's 475, but okay. You're fine. It's okay. Okay, so now if I go back over here, this s that looks like a 5 is actually a 5. So dA dt is equal to 12 times 5, because 5 is s, right? I'm not making it up, or it's not that I can't read my handwriting, times negative 19 over 3. So what's 12 times 5? 60. So dA dt is equal to negative, don't forget your negative. So I can say negative 60 times 19 over 3.
Yeah.
And then I need units, right? What are my units?
B squared.
You want to stop? Oh, you know what I could have done? Yeah, I did that differently. We can reduce this more, right? Oh, no, it's like, I should use a different color there. Can I divide that? 20 times 19. What's 20 times 19? 19 times 2, and you add a 0, so it's what?
It's
380. 20 squared is 400. You subtract 20, 380 feet squared per minute. Yeah. Do you see that it is a process? And I can't tell you you're going to do it the exact same way every single time. What I can tell you should do the exact same way every time is write all this stuff down. Start taking, if you know you need a derivative, take that derivative, substitute stuff in. See what else you can find. Maybe use the other formula if they gave you more than one. Yes, we good? Okay, you want to take over, Miss Bruce? Show them your expertise.
The left-hander.
The left-hander.
Oh, yeah, microphone.
Yeah, the microphone.
No.
Devin, you all right?
Yeah.
Okay.
Wake up.
Okay, so now we're going to look at some actual free response questions, guys. Did you say no? Okay. Well, so what I did was I went through like probably the past 7 years of exams to see how is this tested? Like, what does it look like? And it's always hidden within a problem. Okay, so for example, this one, I want to say this one was 2019. I don't remember which part it was. I think part B. Okay, so it's always like hidden. All right, so what do we got here? I'm going to try to use your strategy. Oh, thank you. Thank you. My students told me that today too. Thanks. I'm going to wear this more often. Okay. So guys, I call these story questions. I don't call them word problems. I call them story questions. At least 3 of your free response questions will be story questions. Cylindrical barrel with a diameter of 2 feet. There's no what? All right, so guys, water's draining through a valve, not shown. So we got water leaking out of this thing, okay, somehow. All right, rate of change of height with respect to time is given by this function. So look, they gave us the derivative of h, okay? H is measured in feet, time is measured in seconds. Now they do give us this formula, okay? Typically cylinders, spheres, cones, they'll give you that formula. All right, so determine the rate of change of volume with respect to time when the height is 4 feet. All right, so I'm going to do something real quick, and then I'm going to use Miss Finnan's strategy. Okay, so when I do these, I write down, you write so neat on this board, and I struggle. Find. All right, what's our goal, guys? What are we trying to find?
The rate of change of volume.
Okay, translate that into a calculus expression.
R.
dV dt. All right, so I write myself some notes. I am trying to find dV dt. All right, and when? With respect to time. When? All right, so when height equals 4 feet. And guys, what are we given in order to do this? Okay. we're given the diameter, and we're also given dH dt, right? Given dH dt. All right, so I typically, this is how I have to work through it in my head. I got to write down what I'm trying to find and when, okay, at what instant. And then what are we given to work with, all right? So let me use your strategy. So you would write down, okay. So dH dt, all right, so that formula, dH dt depends on h, negative 1/10. Guys, what was height measured in? Feet. What's time measured in? Okay, so this quantity would be feet per second. All right, so we're going to dH dt, the rate of change of height, and then the corresponding height, so 4 feet. All right, what's our goal? Our goal is to find dV dt. So find dV dt. So that's going to be the unknown in this question. So what are the, and look, indicate units of measure. So let's do that right now. What's volume measured in? Okay, feet cubed. And time is measured in seconds. And guys, on some free response question, there's a whole separate units point, okay? And this happens actually quite a bit. So what we do, and we usually score that point first, so we just go look at A, B, C, D. If you have the correct units in all four parts, you automatically get the units point. Okay? You can even make up a number, put the right units on it, and still get the units point.
Really?
And it's very obvious when kids do it. Teachers like train their kids. If you don't know how to do it, at least write a number and put the correct units. Okay. You won't have to do that, yo. You won't have to make up a number. You'll know how to do it. All right. Do we have the volume? Okay. What else? Okay, what do they give us? What else do they give us in this problem? Diameter. And guys, when I look at the formula for volume, pi times the radius squared times the height. So if the diameter is 2, then what's the radius? Okay, good. 1 foot. What did I forget? Okay, the units on this one, so feet cubed. That's such a good strategy, guys, to do units first. It really is. All right, so because they gave us diameter, and we know the relationship between radius and diameter, we now know the radius. All right. So then, do we know anything about dr dt? Do we know anything about how fast the radius is changing? No? Nothing? The radius is constant. This is a fixed cylinder container. Now the height of the liquid is changing, but the cylinder itself is a container. So the radius is constant. So what do we know about the rate of change? 0. 0 feet per second. All right. So there's 2 ways we can handle this. If I were to take a derivative right now, okay, knowing that we need dV dt, this is my unknown, right? This is what we're trying to find. So we will have to take the derivative of volume with respect to time. So if I were to take a derivative of volume with respect to time, what rule would we use? Product rule. Okay, so if I were to use product rule, forgot you do product rule differently. I would end up with an equation that would require radius, the height, the rate of change of radius, and the rate of change of height. Okay, and so we would have to determine, we would have to work ourselves through that the radius is constant, so dr dt is 0. Or the volume of this container, the radius is not changing, right? So we can substitute for the radius prior to taking derivative. Okay, it's a constant, it's not changing. So we can never make substitutions for quantities that change until after we take a derivative. But the radius is not a changing quantity. Okay? So, all right, big, I guess. I'm going to make a substitution before we take a derivative. So we have pi, 1 squared is 1. So hold on. Don't make a substitution for height because height is a changing quantity. We're not talking about the height of the cylinder itself. We're talking about the height of the water. Okay? So I made a substitution for radius because the radius is not a changing quantity. The radius of the surface area of that water is not a changing quantity. The height of the water in the container is a changing quantity. So I cannot make a substitution for h until after we take a derivative. All right, so let's take a derivative with respect to t. So dv dt. What is it? Well, I could do product rule. What's the derivative of the first? What is pi is? A constant. There you go. So I don't have to do product rule. It's like the derivative of 3x is just 3. I don't have to use product rule. So it's pi times dh dt. Everybody okay with that? All right, so remember, our goal is to find dv dt. So dv dt requires that I know dh dt. We know dh dt? Okay, dh dt depends on h, and we're looking at the instant that h is for. All right, so dv dt equals pi negative 1/10 square root of h, which h is 4. Now, could I stop right there?
Yes.
Okay, as long as I add what? The units. Okay. Wait. Yeah. No. Yeah, that's what we're trying to find, right? dv dt? Okay. So could I stop right there as long as I put my units on there? What are the units of dv dt? V cubed per second. Did you have a question?
I was waiting for you.
Oh, I was in your way.
Sorry, that takes me away.
All right, any questions on this one?
You can stop, but this one's not that hard to simplify.
What's the square root of 4? 2. And then,
Negative 1/5 pi.
okay, so if it were a multiple choice question, what do we got? Negative pi over 5 cubic feet per second.
And that's it, actually. It's a time test.
All right, can we get through the next problem in 5 minutes?
Yeah, do it your other way,
Okay.
and then I will redo it the other way, but you don't need to.
Okay, height of a tree. Okay, we're gonna go through this a little bit quicker just because of the time. I'm watching the time. I have till 55, is that right? All right, height of a tree in meters. Okay, given by function g. All right, I'm gonna write something down. The height of the tree is given by g. So I'm gonna make myself some notes. G is height. All right, and it's given by that function where x is the diameter. X is diameter. All right, when the tree is 50 meters tall. So 50 is what, guys? G. Thank you. So I'm going to write this down. When G equals 50, the diameter of the base of the tree is increasing at a rate of 0.3 meters per year. So diameter is represented by x. So this would be the rate of change of x. So dx dt equals, it is increasing, so the rate of change is positive, 0.03 meters per year. All right, so according to this model, what is the rate of change of height? Okay, so what are we trying to find? There you go, g dt. So that's why I made this note right at the beginning. Anytime they talk about height, that's g, okay? All right, so we're trying to find the rate of change of height with respect to time. So find dg dt. All right, so this is like my way of saying, find, this is what my goal is, find dg dt. Okay, when g is 50, okay, at the time when it's 50 meters tall, so that's a height, so they gave us g. And then given dx dt, the rate of change of diameter. All right, so I'm going to do this one way, and then Ms. Fennett will do it again tomorrow. All right, so what do we have? They give us a formula. They give us g as a function of x. All right. Where x is the diameter. All right, so this is our goal. We need to find dg dt. So I'm going to find the derivative with respect to time of g of x. All right, remember chain rule? When we do chain rule, we take the derivative of the outside, leave the inside alone, times derivative of the inside. Yes? Okay, so I would say g prime of x, and then times the derivative of the inside with respect to t. Okay, with respect to t. So I'd multiply this by dx dt. And then another notation for g prime is dg dx. Sorry, another notation for g prime of x is dg dx times dx dt. Now guys, can you see these fractions, if I were to multiply these fractions, how these dx's would divide out and then leave us with dg dt? So guys, dx dt is given. Okay, that's 0.03. So all I have to do is take a derivative of g with respect to x. Okay? So we're going to take this derivative with respect to time, but I'm going to do it like this. dg dx, take the derivative of g with respect to x, multiply by dx dt. All right, when we take a derivative here, what are we going to use? Quotient rule. So what do we got? Oh yeah, you'll do it different. So derivative of the top, 100, times the bottom, minus, what comes next? 100x times derivative of the bottom, which is just 1, all divided by the bottom squared. 1 plus x, that quantity squared. Group it squared. So guys, there's your dg dx. We took a derivative of g with respect to x, but then we have to multiply that by dx dt. dx dt. Okay? And this would give us the derivative. Sorry, my handwriting's missing. All right, so the derivative with respect to t of g of x. There's our dg dx times dx dt. Where? Thank you, thank you, thank you. Okay, pause for 1 second. I know the bell's about to ring. Oh. Okay, what do we need, guys? What do we need? We have dx dt. What am I missing in order to find dg dt? How do I find x? How do I find x? Guys, what do they give us? They give us x, they give us g. We have the relationship between g and x. So given g, we could find x. Given x, we can find g. So we would have to use g to solve for x. Okay? The misconception on this problem was a lot of people misinterpreted this 50 and plugged it in for x instead of g.